So for lesson 9.2, we are now moving from reflections onto translations. So of the few that we're going to learn, translations typically is probably I would say the easiest to do on these visually. It has a lot to do with just a shift, right? It's like taking an object and sliding it across your paper. So we can slide it up and right, we can go down and left, we can go up and left, on and on and on. So that's all these guys are. So when we see the word translation, that is one type of transformation, but we usually want to associate the word shift with this guy. So when we see the translation, that is just a shift. So we're going to slide this guy to the right or to the left or up or down, but it's just a shift or a slide of an object. So in this case, one thing you're seeing down here, we're not going to get into vectors in this course. However, I'll just at least tell you what this is. A vector is a vector because it has two components to it. One is direction. Like you can see, this one goes this direction. And the other one is something we call magnitude. Magnitude is simply the length of the vector, right? And so it not only tells me what direction to go, but it also tells me how far to go. So it tells me both of those things. So as I look at this vector, it's telling me to go to the right exactly this distance right here. So let's just say that's 1 inch. So if that vector was exactly 1 inch, then it's simply telling me to take each one of those 4 vertices and move it 1 inch that direction. Okay, so I'm going to take point U, and as best as I can visually here, I'm going to move it exactly parallel to that vector and the same length as that vector. So here is my U prime. That would be my image. Let's do the same thing with T. So again, I'm going to try to keep all this parallel to my vector and the same length as my vector as best as I can. Again, this will become a little more precise when we do it in a coordinate plane on the next page. This is more of an introduction. So let's try the same thing with V. I'm going to move it parallel to my vector. And to try to keep it as the same length of my vector as best as I can, do the one more time with W. So if this were perfect, then the 4 lines that I just drew would all be parallel to this line, and they would be the exact same length as that line. And if I were to do that precisely, then I would find that my image would be identical, perfectly congruent to my pre-image. Again, remember this term that we're going to be mentioning all chapter long, this idea of isometry. Isometry simply means that if I do a translation, then my image is congruent to my pre-image, right? The 4 lengths, and I know mine's a little crooked because I'm not an artist here, but my 4 lengths of my image should be congruent to the 4 lengths of my pre-image, and the angles as well. So like angle W, W prime should be congruent to angle W, right? Like VW, V prime, I'm seeing that W right there, V prime would be congruent to V, right? All of my corresponding parts should match, right? They should all be congruent to the original. So anyway, that's the idea of a translation by vector. But we're going to focus on doing these translations by given a rule, typically. So in this case, now they're telling me the vector, but they're giving it to me with like exact values. So I don't really have to do this one visually. I can just use some very basic math to apply a rule. So here's all we have to do to apply a rule. When I see a vector rule like this, instead of the arrow like I was seeing on the previous page, this is a little more precise. Right, so these guys are going to line up nice and perfectly in a coordinate plane. All this means is if it's positive, you're going to add. If you see a negative value, you subtract. So what this is telling me is to add 2 to all of my x coordinates. This is telling me to subtract 1 from all of my y coordinates, right? And so they took those 4 points and they wrote them down right here. Those are the pre-image. And all they did was take those points and applied this rule. They added 2 to all of the x's, right? And so they're telling you, here's the rule. Add 2 to all of your x's. And they're subtracting 1 from all of the y values. So again, here's the rule. Subtract 1 from all of your y values. So guys, there's really 2 ways that you could get a rule for this. They can give it to you as a vector, and it still tells me to add 2 and subtract 1. Or they can write it out this way. Typically, I prefer this method because it's like super straightforward and obvious. Add 2 to your x's, subtract 1 from your y's. So you can also get the rule this way though. And so here's our translation. So notice they added 2 to all of these x's in order to get the new x's. They subtracted 1 from all of these y values in order to get the new y values. And so if you look at the points that got plotted over here, again, here is RECT, the original. That's the pre-image, short for rectangle, very clever of them. But that would be the pre-image. And then you see R prime, E prime, C prime, T prime as the image, right? So here's the image points that we see right here. Right? So those are my image points. So you can see all they did was shift this rectangle to the right 2 and down 1. So here's the other idea that I want to make sure you see on this, is when you get the rule, whether it be in vector form or in this form, what I want to understand is this is going to move me left or right, and this will move me up or down, right? So when I look at this, if it's a plus, I know it's going in the positive direction. It should go to the right. On this guy, because it was a minus, it should move me in the negative direction, so it's going to go downward. So when this is positive, it goes right. If it's negative, it goes left. When this is positive, it goes up. If it's negative, it goes down. So when I see this figure, all we did on this is we shifted it right 2 and down 1. So here's the visual approach. If I have the graph of the original problem, and I understand what this rule is telling me, that it's going to go right 2 and down 1, all I have to do is put my pencil on the original set of points, the vertices, and go right 2, down 1, and there's my image. I could do that for each point, right? So here's T, right 2, down 1, and there's T prime. Right 2, down 1, there's R prime. Right 2, down 1, there's E prime. So that's the visual approach. The visual approach is to say, okay, I'm going to plot the original. I'm going to go right 2, down 1, and get my new set of points. If I want to apply the rule, then algebraically, I'm going to add 2 to all of my x's and subtract 1 from all of my y's. Here's my new set of points. Here's my image. And I'm going to plot those points and connect the dots. That's applying the rule. So you can really take either approach. We're going to just practice 2 of these. And I'm going to do 1 of each. So in the first one, I'm going to apply the rule. And in the second one, I'm going to take the visual approach. So I'm going to do 1 of each here. So I have a 4-sided shape. That's a quadrilateral, TUVW. And I'm simply going to apply the rule to these. So I'm going to start out by just plotting these. So T is at -3, -8. U is at -6, 3. So I'm going to -6, 3 for point U. We got 0, 3 for V. And 3, 0 for W. So here's our quadrilateral, our 4-sided shape. So there is the pre-image. So if I just want to apply the rule, then I would need to look at these numbers and apply this vector. So remember what this tells you. If it's positive, you're adding. If it's negative, you're subtracting. So this is telling me to, I'm going to write it this way, to take my coordinates and do two things. Add 4 to my x's and add 5 to my y values. All right, so that's the rule that this vector is implying right now. All right, so I like writing it this way. I think it's a little more clear to us in terms of what we typically use. So I'm going to take t, which was -3, -8. I'm going to apply the rule, and I'm going to add 4 to my x. So if I did -3 plus 4, I get 1. I'm going to add 5 to my y value. -8 plus 5 is -3. And there's t prime. So I'm going to graph t prime at 1, -3. Maybe I can try to use a different color for this. Make it a little more clear. So we'll do the red ones as my prime marks. So let's keep going on that. So point U is at -6,3. U prime. Again, add 4 to my x, and that would give me -2. Add 5 to my y, that would give me 8. So U prime is at -2, 8. Keep it going. V is at 0,3. So V prime, if I add 4 to my x, brings me up to 4. Add 5 to my y, brings me up to 8. So V prime is at 4, 8. I hate when they use U and V. It can be a little unclear if you don't try to make this super neat. And then the last point for W is going to become W prime. So if I add 4 to my x, puts me up to 7. Add 5 to my y, puts me at 5. So 7, 5. And I'm looking at W prime. Again, this shape should be perfectly congruent. All my sides and all my angles should be congruent to the original shape. It's just been shifted. So we took the blue graph, and again, what does this tell you to do? Right? A +4 in the x would mean to go right 4, up 5. So we simply took each point, went right 4, 1, 2, 3, 4, and up 5. 1, 2, 3, 4, 5. There's our new point. So that's all we had to do for each one. So let's try that on the final problem here, is just to take the visual approach. So I'm going to graph my 4 points. So A is at 1, 6. 1, 2, 3, 4, 5, 6. So there's A. So again, to get A prime, all I'm going to do is apply this rule to it. The rule here is telling me to go +3 on the x, which means right 3, down 2. So if I went right 3 and down 2, I have A prime. Just by kind of using the visual approach here. So point B was 4, 5. So 4, 1, 2, 3, 4, 5. Here was point B. If I go right 3, down 2. So 1, 2, 3, 1, 2. There's B prime. D was at -2, 0. Again, according to the rule, it's right 3, down 2. 1, 2, 3, 1, 2. There's that guy, and one last point. Oh, I skipped point C. Point C was at 1, -1. So C started right there. And he's going to go right 3 down 2. So 1, 2, 3, 1, 2. And I got C prime. And again, visually, that's all we have to do. I should start mixing those colors. So here was the pre-image. Here is my image. Again, notice isometry, right? Identical congruent shapes. All we did was shift it. We took the blue graph and we shifted it to the right 3 and down 2, and we get a congruent figure at the end of it. So that is it for section 2.